Well, good morning, good afternoon, and good evening. Wherever you are joining us from around the world, thank you for taking the time for being with us today. I'm going to just set the context. Most products today use AI as a feature. So it could be an alert, a recommendation there, maybe a chatbot. They're all useful, but they are still very reactive, right? So this webinar is about that shift from reactive to agentic behavior for futuristic machines, devices, and products that can understand what you are trying to do, anticipate what's next, and help you safely without you having to micromanage it for every step. So I'm going to ask you to hold on to that specific thought for a moment, because we are not talking about adding more AI. We are talking about a different kind of product experience. So let's explore that together, how agentic AI is redefining devices, machines, and edge systems, and how you can lead that transformation with MosChip. And by the way, if you have any questions, feel free to type them out in the chat box, or we'll take those questions towards the end and we'll try to answer them as we go along. I will start off with the introduction today. My name is Smishad Thomas, and I take care of marketing for the digital engineering practice at MosChip. And I will be one of the presenters today alongside Rakesh Nakod, who leads our AI engineering division. Before we get to the actual topic, though, I would like to start off by giving you a brief about MosChip. MosChip is a publicly listed company, pure play engineering services company with over 25 years of experience building silicon and products for semiconductor companies and OEMs. So we work end to end, right from ASICs and platforms, hardware and embedded, all the way through digital and AI. So customers can actually co-design complete hardware, software, AI solutions with one single engineering partner. And that's important for our topic today, which is on agentic systems, because they don't live in the app layer, right? They have to operate seamlessly across device and cloud layers and still meet real world constraints. What are these real world constraints? Compute, latency, power, thermal limits, connectivity, and safety. Those are the questions that we normally are faced with. So that full stack engineering foundation is what turns agentic AI from a demo into a dependable product behavior that is happening at scale. Now, agentic AI, I believe, has moved very fast from research conversations to product roadmaps, and it has even influenced real-time investment decisions. So today, instead of starting off with a question like, what is agentic AI? I would rather start off with a more practical question. What happens when machines stop waiting for instructions? See, because I believe that agentic AI isn't just about adding another capability on top of your device. I believe that it's a structural shift from systems that respond to systems that initiate. So if you look at the last decade or so, we went from automation that mimicked tasks, so that is RPA, to AI that predicted outcomes, to models that could generate content. And the next step in that journey is agentic AI. And agentic AI will enable the next generation futuristic machines, devices, and edge systems. And these futuristic systems don't just automate, predict, or generate. It can understand a goal. It can make decisions. It can take actions, and it can adapt to the user, all the while staying within the guardrails that has been set by the user. Now, before we dive deeper into agentic AI, I want to start you off with 5 specific questions that you'll have to keep in your mind to know whether your product is future ready or not. These questions would be, Can it teach users how to use it better? Can it prevent failures before symptoms pop up? Can it explain decisions clearly? Can it operate autonomously? And can it adapt to different personas? Like it could be an operator or a service engineer or a supervisor or an end user. Will it be able to adapt without making that experiencing confusing? So every example that we are going to look at today, it's going to map back to these 5 questions that we just touched upon. All right. So the shift is happening because the expectations of the customer is shifting, right? And that is why always there is a find for new innovation, right? Products are moving from engineering first to experience first, from control to companionship, and from explicit interfaces to ambient context, which would be voice, gesture, and interactions that will almost feel like they're invisible. So people will expect products to get it, to adapt naturally or reduce effort and step in at the right moment, especially when the user is stressed or distracted. Now, I want you to picture a scenario, right? You get into a car after a long day at work. So before you say a word, it notices signals. What is it picking up on? It's picking up on your posture, facial tension, the time of the day, the route that you usually take to your home. It picks up on all of these signals, and then it lowers the cabin brightness, cools the temperature, suggests a calmer route, and switches to a safer driving profile. Not because you configured a setting, but because it understood the context and the intent without you explicitly saying, right? And that's the difference that we are going to talk about today. Not more features, like I said earlier, but a product that behaves like an intelligent assistant in the background. Now, I'm going to take that example a little forward, right? This futuristic automotive example. Picture a driver, having a tense day at work. He's rushing, he's distracted, he's a bit erratic. What would a traditional system normally do? It will give you a beep, it would give you warnings, it will probably give you lane alerts. But here's how an agentic vehicle would operate differently. It tries to understand what's going on, and it will assist safely. Now, if you look at the slide on your screen, there are 3 blocks below. The first one that I'm going to talk about, all these 3 blocks, they show agentic trends. The first one are emotionally aware vehicles, which means that your vehicle is transforming to an emotional aware vehicle. So the system is picking up on cues. What did it pick up on? Facial tensions, posture, vocal tone, sudden steering patterns. So what it's recognizing is the driver's mental state. And based on that, it will quietly reduce stimulation and increase safety support for the driver. The second one is that the car transforms into a companion. So it uses context. So for example, it's using time, the route that the driver takes, traffic, and what the driver is trying to do, and to collaborate towards the real goal, arriving safely and calmly at your destination. So it doesn't take over unnecessarily, it nudges, it explains, and it stays out of the way unless it actually needs to step in. The third layer that I'm going to talk about, or the trend that I'm going to talk about, is health monitoring. So where we are adding another layer of context through the wearables that we wear. And it will integrate biosignals and physiological indicators so that the system can, say, distinguish between a driver who is just driving fast and between a driver who is under stress or fatigue. and responds appropriately according to how the user is behaving. And that's the point, that I'm trying to make, that the vehicle becomes less of a machine you operate and more of a system that understands context and supports the human. Now, here's a statement which I absolutely love to say. Customers don't buy models, they buy behaviors. Why I made that statement? Because in the future, we will not be strapping AI features to products, machines, and ad systems. We will be enabling behavior. And, you hold on to that thought, because that is what we'll be addressing, as we go forward in our discussion today. Now, there will be a question that you might have. At this point, you might be wondering, how does an agentic system actually work? Or how are these futuristic scenarios being enabled? Let me tell you, at the heart of all of this is a simple, repeatable loop built on 4 steps. It's perceive, interpret, decide, and engage. We call it the PIDE model. The first step, perceive. The system just collects signals from real-world scenarios, and often at the edge. The next part is interpret. It turns those raw signals that it is receiving into meaning. So it's combining context, some processing on device, and the deeper reasoning all happens on the cloud when required. Then is the decide step, where you will actually see the agent mindset show up. So based on confidence, policy, and risk, it chooses what to do. Now, here's what's interesting. If the confidence level is high, it will execute the action. If the confidence level is moderate, it will suggest an action. And if the confidence level is low, it will escalate or ask for more information. And finally is the engage step. So it doesn't just act, it communicates, right? It explains what it did and why, and keeps the user in control and the users clear escalations and override paths when the stakes are too high. So this loop is what turns AI from a set of, say, isolated features into a consistent product behavior. Now, once you see this loop, you will also start to recognize some visible traits of agentic systems. Now, if you had a chance to interact with agentic systems, or if you sometime in the future do interact with agentic systems, there will be certain traits that will come before your eyes without you knowing it. You have to understand that they are goal-oriented, right? And they can act autonomously within the guardrails that you set, and they adapt to context and role. They are proactive, and they keep learning over time, and they're designed to be trustworthy. And yep, without trust, autonomy doesn't scale, right? Now that we have talked about the opportunity part, let's talk about what goes beyond IoT. See, IoT delivers data, and agentic systems must deliver decisions. So bridging that gap introduces 3 critical challenges. And I'm going to lay them out one by one for you. The first is grounded context, right? Telemetry, according to me, is not always the truth, right? Raw sensor data alone, I believe, is insufficient. So agent needs a fused context. So it's taking in sensors, logs, environmental conditions, user intent, and historical asset behavior. And all of these must operate within the policy constraints and safety limits. Without grounded context, your decisions will become risky. The second challenge that I'm going to lay down is action guardrails, right? Decisions must bind to real control systems, and agents must operate through defined control points or workflows and permissions, right? Confidence gating, I think safe modes as well, human override, and full audit traits. They are all non-negotiables. Agency without guardrails will eventually become a liability for the user. The third challenge that I'm going to talk about is fleet governance. So at scale, new feature modes emerge. So wrong actions or model drifts or compounding automated decisions, right? This requires continuous evaluation, compliance feedback loops, and secure policy rollouts across fleets. So governance will become as important as the intelligence that you are trying to deploy. And beneath all of this lies another reality, and that is a paradox of choices that you are faced with. Which data sets will you use? Which GPUs will you deploy? Which AI models will you use? Which LLMs will you use? This will not be answered with one technology. So as a marketeer, I've laid out my points, but then there is a part where we talk about, how do we mitigate those challenges? And then we have Agentic Sky as well, which is a solution accelerator that we recently launched. And Agentic Sky helps you to accelerate product development. So to do that part, I'm going to invite Rakesh Nakod, who is our AI engineering expert, and he will walk you through some of the next use cases and how to mitigate those challenges. So yeah, over to you, Rakesh.
Yeah, hello everyone, and thank you, Smishad. As a marketer, you laid down the challenges and you pretty well explained the futuristic machines and their features pretty well. So, for an engineer in me, I think I should dissect and synthesize the solution for everyone today over here. So, so the solution for Agentic is not a single solution architecture. It cannot be either on edge or fully on cloud. It is actually when both of them work together. So let's understand that better. In at edge, the intelligence will be there inside the device, which will enable it to give faster response, real-time responses, that too with privacy, and enable an offline capability, which will allow the agentic applications to run without the network. So this is also necessary for applications that are safety critical and time sensitive, and this is where the responsiveness and autonomy feature of the application starts at the edge. At the cloud, we'll have intelligence that is more of strategic, because this is where heavy compute will take place, because the system is reading data from so thousands of devices, okay, and it is trying to understand a global pattern which it can maintain for long term intelligence, which will be constantly updated through multiple device interactions. Now, to humans, to simplify this interaction between cloud and edge, will be the LLM, which will convert this distributed intelligence and into a simplified natural language conversation. And these conversations will provide you explanations that you can trust, guided workflows that you can that will reduce the friction, and conversations that seems fit to a human. So what is the hybrid advantage that you get? You get edge that act instantly, you get cloud that learns globally, and you get multiple LLMs working for you, which explains things intelligently. So at the end, you get a system where edge devices are locally autonomous, clouds are globally optimized, and the overall design of the application is human centric. So that's the overall solution for you. Yeah. So how to lay the foundation for building this solutions? So before that, agentic AI cannot be built in few models. Like building any model is not gonna give you an agentic AI application. Agentic AI needs to be built in layers. At bottom we have the silicon and sensors through which the machines and devices will perceive the physical world. On top of it, we have the connectivity and intelligence layer, where the interaction between the cloud and the edge devices will be enabled, and among them through different architectures, we can define how they can delegate and do the tasks between them. And top of it, we have product layer where machines and devices will exhibit the agentic application features, where you will see applications that can assist, that can anticipate, that can adapt. Now at MosChip, to accelerate these, we have two building blocks. Those are Gen AIoT, which consists of modular and reusable accelerators for connectivity and intelligence. With this, your devices can stay responsive and reliable. On top of it, we have Agentic Sky that turns this intelligence into a behavior so that the system can reason, it can have context, it can explain and scale across devices and clouds. So, with that foundation in mind, let's look at what is Agentic Sky. So before I introduce Agentic Sky, let's think through like what do you need to make a product agentic? It's not just models, like I said earlier. It is actually a repeatable architecture. This architecture we have envisioned using two foundation elements, which is fabric and cores. So the fabric is a reusable foundation built on the perceive, interpret, decide, and engage agentic loop. So this agentic loop ensures that the behavior of the application is consistent across real world deployments and under any edge constraints. On top of that, we have the cores that are reusable behavioral packages, almost like product personas. So let's understand core a bit more in detail. So Agentic Sky core is actually a structured intelligence backbone. If you see this structure, it has fabric mappings, okay, which is the our agentic loop. It enables the agentic AI traits like autonomy, proactivity, goal-oriented, adaptability, and continuous learning. These two things are then fine-tuned for different roles, functions, and dimensions that overall package and create an application that can fit for a specific industrial domain. Now, these are the things that you see as a behavior, but what works is the core architecture. So there will be LLMs, the planners, there will be tools and APIs, there will be memory, data, there will be multiple agent collaborations happening, there will be frameworks coming into picture. So all these are making part of our agentic sky. Okay, this is not working well. 1 second, let me go to the, yeah. Okay, so what are the key benefits for the OEM? Okay, so strategically, OEMs will get systems that are autonomous, adaptive, and even persona-centric design. Operationally, you shorten your time to market because you are reusing the cores, and that can work across different industry. From business standpoint, you're reducing your engineering efforts as well as it lowers your R&D cost, and you can enable premium features for your customers. Technically, you get a hybrid ready architecture that can scale across devices as well as cloud. So this setup then puts us to the next question, like how do the cores look like? So before I introduce you to the course, my colleague Smishad had presented a slide where you saw the statement, consumers don't buy models, they buy behaviors. Now I can add a new thing to that statement, that they buy behaviors and Agentic Sky can enable them for you. That's the power of Agentic Sky cores, because reusable behavioral packages are ready as cores that you can fine tune and deploy them. That saves your time to reinvent the same pattern for multiple devices again and again. For example, Vision Core will turn your cameras into proactive guardians. HMI Core will convert your interfaces into contextual assistants. Controller Core will convert your control systems into adaptive orchestrators. Variable core will convert your variable devices into coaching and predictive applications. robotic core will convert your machines into arms or devices that will think, act, and reason with an intent. So all of these are actually enabling agentic AI traits in your futuristic product behaviors, which are autonomy, proactivity, goal orientation, adaptability, and continuous learning and trust. So let's see a deep dive into few of all of these cores. So first is a variable core. So we'll understand this with a specific scenario. Now we are actually doing this for one of the football clubs in India. They are called as Kerala Blasters Football Club. So we are actually enabling a customized variable core for them. So taking an example out of it, imagine a scenario that it's 10:30. The player has actually had a high intensity match. He feels a little sore, nothing unusual. But when the devices or the variables see this deeper, then it identifies different signals like recovery signals, basically your vitals, which is sleep quality, heart rate variability, resting heart trend, and load imbalance. And then it interprets these patterns as something that, okay, the recovery is not complete and it can have an elevated risk. So this core is not only flagging the risk. Now what it will do is it will actually go ahead and prepare a schedule for the coach and the player, where it will reduce the sprint intensity, replace the high load drills, and prescribe a recovery protocol with a high confidence score, so that after the drill session, the risk score of that uh, athlete is reduced. So this way, variable core is not just monitoring the recovery, but it is also protecting the athlete's future. So now, its variable core is not limited to just athletes. You can scale it across different industries. Like imagine a variable core being used by a worker. It becomes a cognitive worker companion for them, where it will guide them in tasks, help them reducing an error, building confidence step by step. It can also be interpreted as a continuous square loop, where it is monitoring your vitals every day. Then it is giving you prompts to do certain, taking certain breaks, so that you are pretty well in your health parameters. For gamers, also, it can act as a continuous care loop, where it is also nudging you to take breaks, so that you are not so much focused on the gaming that you actually your health might deteriorate if you're that engrossed in gaming and all. So those kind of things can be enabled with variable code. So all these features, all these use cases uh, are having the same pattern, where what we are doing is we are trying to collect more and more information, reasoning that information to come up with the next best steps that we can take for uh, the system. So let's deep dive into Vision Core a bit detail. Consider a scenario that there is a customer who parks his SUV in a parking lot, and he goes for the shopping. When he returns, then the vehicle is gone. Confusion and panic starts in, and in an obvious scenario, what any person will do is he will go to the security. He will ask them, "Okay, I have lost uh, my car is missing." So the security by default will scan through multiple footages, multiple camera feeds. It might take 2 hours or 3 hours. Now imagine the same scenario with a Vision Core, where the security officer just types a string like silver SUV parked around 5 p.m. section B3. With this simple input, what Vision Core will do is now it will fuse all these multiple camera feeds together. It will try to analyze the vehicle attribute of the vehicles and start tracking it across multiple feeds. Now it will try to understand the query context, and according to that, it will find out all the events that are necessary to track, like, okay, when it arrived, when the owner exit, what was the movement across the parking. And then at the end, it will build a visual timeline with all the detailed frames to show how the vehicle came into the parking lot and exited out. And at the end, it won't stop there. it will actually create an incident report with a confidence score where it will capture all the evidences with the confidence score that okay, this is the vehicle that entered and this is the vehicle that exited. So you can imagine that it simplifies this process that take 3 to 4 hours of manual review into a few minutes. No guesswork, no hours lost, everything is swift. So consider Vision Core not limited to just security. It can enable any device that has cameras to become agentic. So consider cameras in a retail store. They can be converted into autonomous shelf where they are watching products. They realize that okay, particular shelves need there is a misplaced SKU, or there a particular shelf is having a less number of products. Then it can automatically trigger a replenishment in manufacturing lines. There are certain defects that people cannot identify, but we need different sort of cameras. It can select, Vision Core can select what camera needs to be used to identify a specific kind of defect and propagate that defect and identify it appropriately. So these are all the scenarios, futuristic scenarios that can be enabled with Vision Core. Can I have a water? 1 second, please. Yeah. That. So moving on to next core is the HMI core, where experience really matters. Again, let's understand this with a example. Like it's a Black Friday sale. The store is packed. There are so many people waiting to purchase their products on sale. You are also one of the buyers who want to buy a television, and there are so many options of television: 4K, QLED, 120 hertz. Even after that, you also have your own requirements for purchasing, like what kind of television, what is my budget, what are my room requirements, where I want to accommodate. So all this information, uh, along with all the flooded knowledge that the sales has to offer, makes it confusing for you to select what is the best pick for you. But imagine an HMI core agent now acting as your guide. You give all your requirements, and it has all the knowledge of the sales at that point of time. It will it will transform all this data and recommend you a very clear pick, also giving you a breakdown that why it thinks that this is the best television for you. So here you see that the agents not only understand the intent, but it also understands that what things you will need better and what will be good for you in the long term. So at the end, you leave as a confident buyer where you don't regret what you bought. So HMI core cannot be limited to again a single industry. If you see, it can enable as a digital nurse where patients incoming can ask questions to this digital nurse and it will answer them. It can guide patients to find appropriate doctors, and it can escalate certain situations to doctors when necessary. It can also become an situational awareness HMI where you're trying to interact with a complex machine, trying to come up with a setting, but you're not confident enough whether the setting will work or not. Then it realizes and it prompts you that okay, it can guide you to get a particular setting, or it can guide you to get a correct calibration. It can act as a negotiation partner where it can simulate arguments. You can rehearse along with it and come up with a plan to execute your deal. So these are all the things that can be enabled with an HMI core. Okay, this is what working properly. Okay, going back to controller core. Controller core is built for places where you need actions without any delay. So understand that to understand that better, again, I'll bring up a scenario where imagine there is an electronics manufacturing plant. Uh, it's night shift, and there is a fault that occurs in one of the arms, and probably it causes a spark. heat begins to rise, the smoke particles appear. They are microscopic, so no operator or they are not visible on the camera itself, but the sensor sees it. Now, instead of just raising an alert and acting it, what the controller core will do is it will first identify and assess that particular thread, like, okay, how critical it is, what is the or how it can propagate and where it will escalate. Once it has interpreted that information, it will decide, it will isolate that particular affected circuit, and it will reroute the load that was there at that machine to other machines, and it will try to activate certain suppression mechanisms, pre-built suppression mechanism for such scenario. After doing all of that, it will do is it will now create a summary report. It will highlight what impact this thing had, what was the root cause analysis, and what action it took for managing that. So in this overall scenario, if you see that this incident did not water down to something which is very big where plant had to shut down, or some outward incident happened, it managed that incident, it stabilized the plant autonomously. That's the power of the controller core. And we cannot keep controller core again in a single industry. It can spread across various industries. For example, if you take it as it can become a predictive ICU sentinel, where it is monitoring your vitals, it is reading multiple data from the multiple health devices. Then it can predict whether your health is getting deteriorated and take an necessary action. Now, smart homes are becoming more and more smart with devices. To manage the smart devices, you will definitely need a controller core where it will enable these machines to become more ambient. Just by your presence, it will understand what lightings needs to be set depending on the climate outside. It will fine tune this lightning based on your energy requirements. It will make corrective decisions. So all these things can be enabled with controller core. Now, lastly is the robotic core. This is the core where intelligence actually made physical execution. So, for an example, you can take an industrial scenario where there is a robotic arm where it actually is sorting a product. So, products have multiple variants. So, let's consider an example that there is a product A and there is a product B. So, the robotic arm was sorting product A. Once so suddenly it started getting product B for sorting. Now, instead of identifying the dimension changes from product A to product B as a defect, it realizes that, okay, this is not a defect. And once it identifies that this is not a defect, what it will do is now it will adjust its grip force and alignment, so that it can pick up this new product variant accordingly, and it will inform the other robotic arms in the production line of the change. So that way, without having any downtime or reprogramming of the production line, it autonomously manages the situation and stabilizes the operation for you. Now, robotic core cannot be limited to just this. So, the example that we discuss right now is mostly as an self-directed inspection arm. It can also become a self-healing arm where it is reading everything about its self, like vibrations, how it is operating, how long it is operating, what is its speed, and if it needs maintenance, then it itself will initiate the predictive maintenance process. This can be also expanded to robots that are at home. Most of the people have a robotic cleaning companion. So, robotic core will enable future features like they can identify occupancy of different rooms at different point of stage at in a day. Which rooms should be prioritized if there are leaks? Does it need to create an isolated area so that it doesn't turn into an accident? All those features can be enabled. So as you saw across all the cores and all the examples, uh, it is clear that the pattern, though the scenarios are different, we are following almost the same pattern, which is getting more and more information, reasoning, creating making sense or intent out of that information, and then taking an appropriate action. This can be only enabled with agentic AI. Now, you might be wondering why we have discussed so many scenarios. The reason is actually we want to showcase that how powerful agentic AI is. Okay, and if you want to build your products, then you have to enable this as early as possible. So, with that, I would like to hand over the discussions again back to Smishad. Yeah.
So thank you, Rakesh. I hope that gives you a fair bit of idea about the power of agentic AI. We also saw how we could mitigate some challenges that we would face. And we also talked about the powerful agentic sky and the different cores that it has and how it can enable different products or edge systems or devices, right? So obviously, if we move forward from here, there would be uh, we will have to answer some readiness questions. So a winning product doesn't really wait for perfect commands. It understands what you're trying to do. Doesn't just flash, a bunch of commands or anything, or it does not flash some alerts. It does not behave like a black box. It tells you what it is doing and why. It also knows when not to act. Okay, because if the confidence is high, like I said earlier, and if it's within the written policy, it will take action. If not, it nudges you and it will ask for a confirmation, or it escalates. And override is always an option that you have. And the experience changes based on who is using it. For an operator, let's just assume it gets simple guidance. For a technician, it gives deeper diagnostics. And for an end user, it just uses plain, simple language without making that whole product feel complicated. And that's what agentic ready looks like in the real world. So this is the strategic takeaway. And in the next phase, the advantage isn't just shipping faster. It's about earning trust. So it's not done by collecting more data, but it's done by showing real contextual intelligence, understanding what's happening, what matters right now, and what the user is trying to achieve. And it won't be also one with a long list of features. It will be one with reliable behaviors, products that do the right thing consistently, especially in the moments that matter. So over time, that changes the relationship. The product stops being something that you use occasionally, and it starts feeling more like a companion. So it is acting when needed. It teaches you, adapts to the user, and it explains itself very clearly. And this is how loyalty and premium positioning are built in the agentic era. Not by promising autonomy, but by delivering dependable, understandable help. Right. And that brings us almost to the end of the session today, but don't go away just yet. Just wanted to thank you for being here. And I hope this gives you a clear picture of what agentic behavior looks like in real products and how agentic AI will help you bring about that transformation. Now, if you have questions, please type them out in the chat window. Now would be the time for us to take those questions, and we'll try and answer those. I'll tell you, if there are certain questions we cannot answer right now, we'll take it up and drop it to you as a reply as well later on. And yeah, there is a small bit of surprise that we have for you. You see a QR code on the screen, and since you have joined us today, we would like to give you an early access to our white paper, which is called When Products Anticipate and Assist. So it will come to your inbox as well if you go to scan the QR code and go to the landing page. And if you want to understand more about Agentic Sky, drop a yes in the comment section, and we will try and get in touch with you. Or you could also use the contact information on the slide and get in touch with us as well. So